Hello there, Mr. Chan here for Algebra 1, about to do 9-2, solving quadratic equations by factoring. Please grab your note takers and turn to page 193 and let's get started. I'm actually going to skip this opener talking about pixels and artists on an entire wall. Let's go to the next page, 194. Let's go. So this section is called factoring and solving equations. What we're going to do is apply something called the zero product property. Basically, it says this: if A times B equals 0, meaning if you multiply two things together and they equal 0, that means 1 equals 0, one factor, or the other one equals 0, because the product equals 0. One of them has to be 0 or both, okay? So that's called the zero product properties. A and B are the factors. Now, in this case, with quadratics, the factors are binomial, okay? So keep that in mind. Why are we doing this? What we're saying is this: when you have a quadratic, ax squared plus bx plus c equals a function, or y, when you change that y into a 0, and then you factor your quadratic into a binomial times a binomial, what we're doing is when we set y equal to 0, we're saying that we're trying to find x-intercepts. Setting y equal to 0 means we're finding x-intercepts. Now, x-intercepts are also known as, in algebra, roots, zeros, and solutions. They all mean the same thing. Think about what a parabola does, right? A parabola could hit the x-axis in two spots. There are two answers right there. It could hit the x-axis once, maybe. And sometimes it may not even hit it at all. So those are the three scenarios that can happen. What we're doing now is taking the idea of factoring a quadratic and solving the actual points through which the parabola crosses the x-axis, okay? Take a look at number 1 here. We have 1a, 2x minus 1 times x plus 3. Now the 2x plus 1 is kind of like the letter A from above. And the other one, x plus 3, is like the letter B. And it's already equal to 0, so that means we have something times something equals 0. That allows us to split up and solve them separately. So 2x minus 1 equals 0, or, let me put that line down here, whoops, or x plus 3 equals 0. You treat them as separate equations. So here, let's do that. Add 1 to both sides. Great. On the first factor, whoops, don't need that anymore. And divide by 2. So one of our x-intercepts or solutions or zeros is x equals 1/2. If you graphed 2x minus 1 times x plus 3, it'll graph a parabola through which it will cross through positive 1/2. Let's solve the other one. Oops. Subtract 3 to both sides. We get an answer of x equals -3. So going back to the whole idea of a parabola, if I were to FOIL this particular problem, 2x minus 1 times x plus 3, I will get a positive a value or leading coefficient, right? 2x squared. Which means this parabola does open upwards because my a value is positive. So this, I'm trying to summarize it briefly. The two answers we just got, -3 and positive 1/2, is where the parabola crosses the x-axis. That's all I'm saying, ladies and gentlemen, like that. It opens upward, okay? Those are your x-intercepts. Yay. Letter B is the same way. Let's solve that individually. We have something times something equal to 0. Split up and solve. 2x plus 3 equals 0, or 3x minus 1 equals 0, and solve them individually. Right there. This is where your solving skills are important. Oh, there's one of my answers. X equals to -3/2. And my other one, when I add 1 and divide by 3 to both sides, because right now I'm doing operations, aren't I? And there it is. Yes, they are fractions, but it's still a parabola. It crosses through the x-axis twice. One of them is at -3/2, which is -1.5. Right about there. And positive 1/3. And about right there. It does open upward, as you can see, because if I were to refoil that, I will get, here's that, 6x squared plus blah, blah, blah. It definitely opens upward. Yeah? Okay. Great. So another parabola that crosses through, and I don't know exactly how pretty that is, but it's approximate, close enough. So number 1a, 1b have already been factored for us, allowing us to use the zero product property and solving them individually. 2a and 2b are not factored. It's just like 1a, 1b, but we just have to do one additional step. Okay? Taking a look at 2a, I noticed something interesting. It's a quadratic. It can be guessed very easily. And I realized that 64 and 16 are kind of related. 8, right? Oh, 8 times 8 is 64, and 8 plus 8 is 16. In fact, that right there is a PST, a perfect square trinomial. But let's say you didn't know that, right? You can just start guessing and checking your head. There's only one way to get x squared. That's x times x. And there are a few ways to get 64, but eventually you'll get to 8 and 8. Now this is kind of an interesting one, right? Split them up and solve because of the zero product property. You only have to solve one of them, x plus 8 equals 0. The other one is a double root. It's going to give you the same answer. Let me show you in a moment what that double root means after you subtract 8 to both sides. And when you do that, you'll get x equals -8. There's your answer. That's it. -8, -8. This parabola crosses or touches -8. Right there. It opens upward because x squared tells you it opens upwards. Great. And it doesn't technically cross it. It skims off of there. That's what the characteristic of a double root would show. It kind of bounces off that -8 right there. Okay. Okay. Letter B. Let's take a look at. Oh, this is weird. That 64 is on the wrong side in order for it to be a quadratic. Let's move the 64 to this side and see what happens. This is a little tougher, isn't it? We have x squared minus 12x minus 64 equals 0. This is not easy. Think of all the possible ways of factoring that for -64, right? That's not easy. There's only one way to get x squared. That's x times x. We know that. But negative 64 is definitely challenging, right? You go through a list in your head: 164, 232, 4, 16. One of those somehow is related to the number negative 12 in the middle, right? And looking at these three pairs so far, I mean, I could go to 8 and 8, but I realize that 4 and 16 are definitely linked to the number 12. So let me put that in here, 4 and 16. One of them has to be positive, one of them has to be negative, of course. And in this case, I have a negative 12, which means I need a bigger negative number, right? Aha, there it is. Whew, that was not easy guessing and checking. You might have to break out the box for that if you have to, okay? That's fine. Break out the AC hybrid box to solve that. Now we have something times something equals 0, which means they can be solved individually. We have x plus 4 equals 0, or x minus 16 equals 0, right? This is using the zero product property. Let's go ahead and solve this. For the first x-intercept, I get x equals negative 4, or solution. That's one of my answers, yay. And the other one, add 16 to both sides, of course, and I get x equals 16. And ladies and gentlemen, there are your two answers, yay. I'm going to skip example 3 this year. Those are not required anymore. I'm going to skip example 4 on the next page. Crazy. And example 5. Let's jump to the last page, shall we? Let's see what happens. All right, a bunch of factoring and realizing that we are solving for these x-intercepts. These are solutions. This is where the parabola crosses the x-axis. Let me zoom in a little more so you guys can see better. Oh, yay, number 5, it's already factored for us. Using the zero product property, I can solve them individually. Very good, here we go. Split them up, here we go. X minus 10 equals 0, or x plus 20 equals 0. Solve them individually. Maybe you guys can try that at your desk and look up when you're done. So working on 5 and 6, when you're done, just look up. I'm just solving it quietly off to the side here. Yay. So take a look and see what you have. Hopefully you guys got my answers. Yay. All right. Number 7 and number 8 require a little bit more work. We've got to actually factor it, whereas number 5 and 6 were already factored for us. Thank goodness the A value is 1 for number 7 and number 8. I can just guess the answer with these ones. I'm going to just try to guess these ones, okay? All right. There's only one way to get x squared, right? There's a few ways to get 32, though. Let's play with that one. How about 1 times 32, 2 times 16? Stop! I could have gone to 4 times 8, right? But I already noticed that 18 is 2 plus 16. Ding, 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 ding. There's my answer. Plus 2 plus 16. Set that equal to 0 already. Split them up and solve. Yay. And you may have noticed you can do a lot of stuff in your head already. And we'll get 2 answers in this case as well. X equals negative 2 and x equals negative 16. There it is, number 7. You want to try number 8 by yourself? Just mental math it? Okay. When you're done, just look up. So this section is kind of a nice little connection to graphing why we factor. When we factor, we are actually getting the intercepts, the x-intercepts for which to travel across the x-axis. That's what we're getting when we factor and then set it equal to 0 and solve them individually. Hopefully you got 7 and -3 for number 8. Very good. 9 through 12 is just a bunch of problems to be done. They may or may not require an AC box method, but you do need to move that constant to the other side, unfortunately, for all of them. So let's do that. Okay. Oops. Zoom in a little more. Okay. So number 9, we have x squared plus 2x plus 1 equals 0. Number 10 is x squared minus 8x minus 9 equals 0. Number 11 is 2x squared. It's getting a little cramped here. Sorry about that. It's a little tough one, hard to do. So 11 and 12 might require a box for a lot of you. That's okay. We have a little time. Actually, we're doing pretty good on time, barely 20 minutes here. So off to the left, I'm going to do number 9. Actually, this one's a PST. Psst, nice. And the factors themselves are duplicate. There it is, x plus 1 times itself, yay. Using the zero product property, split up and solve. X plus 1 equals 0. Subtract 1 to both sides, nice. And there it is, ladies and gentlemen, my double root at -1 for a parabola that opens up because of the a value. And it crosses to -1. I mean, if you really wanted to draw one, you could just do this right there, right? There's what it would look like, number 9. Number 10, let's see what happens here. Oh, okay. So this one, we can still get away with guessing and checking, right? Okay, let's do that. This one's going to require, sorry about the computer got out of control here. There's only one way to get x. 9 and 1. I need a -8, which means I got to get that configuration right there. Split them up and solve. Here we go. X minus 9 equals 0, or x plus 1 equals 0. Solve them individually. And same goes right here. Okay. And there they are. That was not too bad. Number 11, number 12 might require a hybrid AC box. So any questions on number 9 or 10? All right. Number 11, let's break that into a box. First term, first box. Last term, last box. Middle term, bottom left-hand corner. Multiply the diagonal, a times c. That gives me -30x squared. What are all the possibilities of -30? When added together will give me +1x right there. And I believe some of you are going to get to 5 and 6. You know, you can get like 2 and 15. One of them is positive, one of them is like, oh, there it is. You just mental math a lot of that. Doesn't matter where you put the x, the 5x, the -5x, and the +6x. But the last step is to GCF each row and column. First row, take out an x. Second row, take out a 3. First column, take out a 2x. And last column, take out a -5. There they are, yay. So we'll have x plus 3 and 2x minus 5. And it works out. Yes, it does. Split them up and solve. Individually, I'm going to use the space for number 13 because we're not going to do 13. Sorry about that. Crampness there. So we get x plus 3 equals 0. X equals -3 is one of my solutions. And the other one is 2x minus 5 equals 0. X equals, you know what? You want to try mental math here? Add 5, divide by 2. Isn't that cool? To be able to try that in your head? Those are your two answers, ladies and gentlemen. Number 12, last one. Woohoo! This one's going to require a box. Definitely, I can't do that in my head. I'm not that good. First term, first box. Last term, last box. Middle term, lower left-hand corner. Holy cow. I hope we can do this. 5 times 18 is 90x squared. Oh, wait a second. Interesting. What times what equals positive? When added together would be negative? -9, -10. What? Did I just do it? I think I did. There it is. -9x, -10x. GCF each row and column. First row is x. Second row is -2. First column is 5x. Last column is -9. I think that works. No way. I think I got really lucky there, didn't I? So we have x minus 2 times 5x minus 9. Split them up and solve individually using the zero product property. There it is. First one's easy. X equals 2. The second one, let's do this. Add 9 and divide by 5, right? There it is, ladies and gentlemen. X equals 9/5 and 2. Well, survived that little lesson there. We are going to skip 13 and 14. Those are not required anymore. Let me know if you have any questions. Thank you very much. Have a good day. Bye-bye. See you next time.